Now we were discussing regarding the majority element, and this is the fourth solution in the same series. As you remember, the first solution is the naive algorithm, which is having order of n square as the time complexity. The second solution is by using the binary search tree, which is having the time complexity as order of n log n. And the third solution that we discussed was using the Murray's voting algorithm, which is having the time complexity as order of n. Now this is the fourth solution is by using the hash maps. Actually this hash map is also having the time complexity as order of n. At the same time it is having the space complexity, which is also order of n. So in case of Murray's voting algorithm, time complexity was order of n, but the space complexity was order of 1. But still it is very interesting to study hash maps also to solve exactly the same problem. Now you know what is a hash map, you know what is a hash table, that we have already discussed in our preliminary courses. Now we need to see how we can use hash maps to solve exactly the same problem here. Assuming that this is the array on which we are going to perform this solution. It is having the values as 4 1 4 4 4 3 2 1 6 4. So index locations are 0 1 2 3 4 5 6 7 8 and 9. And for this, let me add one more 4. So index location will be 10, and this is the array A. Now on every element, we'll take every element, we are going to apply the hashing on this by using the hash formula. Generally the hash formula that we use is key mod n, and it gives us the position in which we are going to store the elements. And here we know the range of the numbers is between 0 to n, which may be 0 to 10, right? So I'm going to use a hash table here, which is having a total of 10 locations, which is index location 0 1 2 3 4 5 6 7 8 and 9. Now the interesting fact is, in this case, in the hash table, we are going to store two values. Number one is the key and second one is the count. How we are going to do it? Let us see. The first number is 4, so we are going to do 4 mod 10, because 10 is the size of the hash table, which gives us the position, which is 4. So I'm going to go to this location 4, and at this particular location I'm going to store this number 4, and now the count is 1. Next time when 4 will be there, then we are going to increment the count as 2. So now next time check this element, which is 1. So I'm going to do 1 mod 10, which gives us the position, which is 1. So hence I'm going to store 1 here, and now the count is also 1. Again increment the value, so next value number is 4. So again I'm going to do 4 mod 10, which gives us the position 4, but 4 is already existing, hence I'm just going to increment the value of count. Next number is again 4, I'm going to increment the value of count. Next number is again 4, I'm going to increment the value of count. Next number is 3, so if you do 3 mod 10, then again you are going to get the number as 3, hence 3 will be stored here and the count will be 1. Next number is 2, so 2 will be stored here and the count will be 1. Again 2 mod 10 is 2, right? And next number is 1, so 1 is repeating again, so therefore the count of 1 will become 2. Next number is 6, so 6 will be stored here with the count 1. Next number is 4, 4 will be stored here with the count 5. Next number is 4, the count will be 6. Now in the meanwhile, it can happen, there may be some more elements after this, it can happen. But as soon as you reach at a certain position where the count exceeds n by 2, at that particular location, we can say that this is a majority element. And this is a very easy solution, as you can see. But the biggest and the major problem with this solution is we are going to use order of n extra space in terms of this particular hash table. Just to create this hash table, we are going to use order of n extra space, but we don't have to go through the entire loop again. And secondly, we don't need two different algorithms. In the Murray's voting algorithm, we needed two different algorithms. Number one is to find candidate of the hash table, and second one is to check whether it is a candidate, whether it is a majority element or not. Okay, so first one was the candidate to find the majority element, and second was to check whether it is a majority element or not. But for this, using hash maps, we don't even need two different algorithms. We can just write one single algorithm or one single solution which can which can find whether it is a majority element or not. Okay, now let us look at the programming implementations of all these solutions. Okay,